Hello! This will be our last video on exponent rules. In this video, we will learn what to do when we have negative exponents. In math, when you write your final answer, for that answer to be simplified, you do not want it to have any negative exponents in it. So these first two rules that you see on this slide are basically the same rule that says when you move a base with its exponent to the top or to the bottom of the fraction, it changes the sign on the exponent. So let's just say I had x to the negative 5 over y to the negative 3. I could change the signs on those exponents. If I move the y to the top, then it becomes a positive 3. And move the x to the bottom, it becomes a positive 5. So moving the base with its exponent over that fraction bar changes the sign on the exponent. Now if I just write x to the negative 8, it is in the top. Even though we don't see the bottom of the fraction, the bottom would just be a 1. And so if I want that to become positive 8, I would just move the x to the bottom. However, I would then need a numerator. So 1 would be your numerator. And if it were already in the bottom and it were a negative exponent, I could move it to the top and it would be positive. But if I put it in the top, there's no need for me to write a 1 below it because x to the 8th over 1 would just still be x to the 8th. And this other rule that you see on this slide says if you have a fraction with a negative exponent, you're going to take the reciprocal. We studied that word when we were dividing fractions. Sorry, I can't spell and talk at the same time here. Reciprocal. So you take the reciprocal of the fraction, and that's going to change the sign on the exponent. Okay. All of these only changes the sign on the exponent. It does not change the sign that's out in front. And we'll see that when we do examples. So in other words, here on this third rule, you're going to just flip the fraction, flip the top and bottom, and then change the sign on the exponent. So let's try some examples. Okay, so number 1, it looks like a to the negative n. So remember the rule is put it in the bottom and the exponent becomes positive. You've got to put a 1 in the numerator. You have to have something written up there. So our answer here is 1 over x to the 4th. To simplify it, in this case, means to write it with a positive exponent. So number 2 is very similar, same rule that you would apply. You would put a 1 in the numerator, the 2 would move to the bottom, and then the exponent would change signs. And since your base is a number, you could go ahead and calculate 2 times 2 times 2, which would be 8. And your answer then is 1/8. Look at number 3. Now we have a negative exponent in the bottom. So let's think of the rule this way. Again, it's really the same rule, but just it's already negative in the bottom. Then what we want to do is write it in the top with a positive exponent. But when we move it to the top, we don't have to write it as a fraction anymore. Now, we happen to already have a 7 in the top. So that 7 stays on the top. It does not move, okay? Its exponent would be a positive 1 if you were to write it. So its exponent's already positive. That means the 7 does not move. The n moves up to the top and multiplies by the 7, and its exponent turns positive. And here it is not necessary to write a 1 as your denominator. You can just leave it. 7n squared. So again, on this case, it's important to realize that the 7 does not move. Look at number 4. Now we have a fraction with a negative exponent. So that's the one that says take the reciprocal, and that will change the sign on the exponent. It will not change this negative that's out front, by the way. Your fraction is still going to be negative on the next step. So I'm going to take the reciprocal, put the 4 on top, the x cubed on bottom, but I still need a negative fraction. I can put it in the middle, or if you want, you can stick it on the top. And now my outside exponent, that's what changes signs. That becomes positive. Okay, then we go back and apply the exponent rule we learned in the last video that says when you have a fraction with an exponent, then that exponent needs to go on the top and on the bottom. So now on top, we go ahead and calculate -4 times -4, positive 16. And on the bottom, we use the rule that says when you have a power to another power, you multiply those powers, which would be then x to the 6th power. And that is the final answer for number 4. Okay, look at number 5. It may look a little crazy and challenging. However, it's not really as hard as it looks. We're multiplying all this together, so I'm going to go ahead and change the order up a little bit. Now, notice we do not have any exponents outside the parentheses. We would have to work it differently if we did, but we are just multiplying these together. So, we're going to take that 3/2 and multiply it by that -12. I'm going to put that as a fraction since 3/2 is a fraction. And we're going to need to multiply the a cubed times the a to the -4 and the b to the -2 times b to the 5th. Okay, so I'm going to do my fractions first. I have a common factor of 2. 2 will go into 2 once, 2 will go into 12 6 times. So then I'll multiply across. I've got positive times negative means negative. 3 times 6 is 18. And 1 times 1 would just make a 1 in the bottom, so I don't need to write that one. Okay, look at the a's. When we multiply, this was the first rule in the first video on exponent rules. When we multiply, we add the exponents. So I'm going to go ahead and write that out. It's 3 plus -4. You keep the base, add the exponents, and the same thing for the b's. You keep the base and add the exponents. So the result of that would be a to the -1 and b cubed. So we do end up with a negative exponent, and so to simplify it completely, we need to make that a positive exponent. Now the -18 already has a +1 exponent. It does not need to move. And the b already has a positive exponent. But we're going to make a fraction because to get this -1 to be positive, that a has to move to the bottom. And it's not necessary to write a +1. That's understood to be there. And so we would just write a. And now it is simplified. You don't have to write this step out like I did, but if it's helpful to you, then go ahead and write it. Okay, we're going to do 2 more. These are going to get a little more challenging as we go. It may involve several of the exponent rules that we've learned throughout these 3 videos. The first thing I want you to notice on number 6 is that you've got a negative exponent on the outside. So at some point, we'll have to take the reciprocal to make that positive. You could go ahead and do that right now if you want, Or you can simplify that inside fraction a little bit and then take the reciprocal. It's totally up to you on the order that you do those in. I think maybe I'm going to go ahead and work it by doing the reciprocal first. So we'll switch these, switch the top and bottom. It does not change the signs on those because we're just taking the reciprocal to make this outside become positive. Now we're ready to work on simplifying the inside. So the 10 over 25, we're going to simplify that fraction. We can divide 10 by 5 is 2, and 25 by 5 is 5. Now let's look at the variables. So I've got an a on top, and it's got a positive 1, so I'm going to leave that a. But this one has a negative, so it needs to move to the top. So I'm going to put it next to my other a that's already there. And now look at our b's. We've got b, and this is an invisible positive 1 on that b there. So that b stays on the bottom, does not need to move. But this b has a negative exponent, so it needs to come down. And all of that is still to the second power. So now we can multiply our a's. We're adding the exponent, so it'd be 1 plus 2 would make a cubed. And on bottom, b times b is b squared. And again, we still have our outside exponent. Now we have simplified the inside fraction as much as we can. So we're going to apply that outside exponent to each factor on top and each factor on bottom. The result of that, if we square the 2, that's going to become a 4. And then this rule, power to a power, is to multiply. So a to the 6th. On bottom, 5 squared is 25. And here we've got 2 times 2, so b to the 4th. And that would be our final answer. So a lot involved there. Just take it one little piece at a time. And again, you know, I chose to do the reciprocal first to change this sign. But you could have simplified inside first and later taken the reciprocal to change that sign. So on these problems, sometimes there are several different ways that you could work and still get the correct answer. Okay, this is our last example. Now, this second fraction here has an exponent on the outside, and that means I can't just start multiplying these together. I have to handle that outside exponent before I can multiply all of these. So let's see. The first thing I'm going to do is go ahead and turn this exponent positive and this exponent positive. So my 6 and my d are going to stay on top. C is going to move to the bottom, and then that will become a positive 2. Keep the parentheses. And over here, I'm going to keep the 3 on top. I'm going to keep the 2 on bottom. The c needs to move to the bottom so that it can become a positive exponent. Now look at your d's. That would involve our division rule that we learned in the last video. The rule that says a to the m over a to the n is a to the m minus n. So d to the 4th over d is d to the 4 minus 1, which would be d cubed. And that would just stay on the top. Another way to know that it's on the top when you're simplifying like this is the variable is going to stay wherever the bigger exponent is. Since the 4 is bigger than the exponent of 1 and it's on top, then my answer would be on the top. Okay, and then we still have our square on the outside. So I've simplified this fraction that is squared as far as I could simplify it. Now I'm going to go ahead and square. So this 60 over c squared, just leave it for now. We'll come back and deal with it in a moment. But we need to square each part of this fraction. So I'm going to not write it out this time. Let's just try to do it by figuring out what the answer to each of these squared is. So we'll start with 3 squared, we know is 9. And d cubed squared, we would multiply the exponents, so d to the 6th. Then 2 squared is 4. And c cubed squared, multiply the exponents, c to the 6th. Now we don't have that exponent on the outside anymore, so we can actually multiply these together. It's up to you if you want to go ahead and do some simplifying first, or you can just multiply straight across. You may notice that 4 and 6, just like with regular fractions, have a common factor, so we could go ahead and divide 4 by 2 and divide 6 by 2. Now I'm going to go ahead and multiply across. So I'm taking 3 times 9 and d times d to the 6th. So I'm adding 1 plus 6. My exponent's 7. And on the bottom, I've got just a 1 would be in front of that c squared. So it'd be 1 times 2 is 2. And then c squared times c to the 6th is c to the 8th. Now 27 over 2 cannot simplify, and these variables cannot simplify because they do not have the same base. My exponents are positive, so that is my final answer. Okay, that brings us to the end of the exponent rules. I definitely recommend that you try hard on those homework problems. These do take some practice. And any of the problems you can't figure out, just circle that, and you're welcome to ask me during class. We will spend time working some together. Or if you need answers and you're not in class, you can always email me.